All right, so y'all have been learning the basics of the order of operations with code, conditionals for code, and loops for iteration. And now you're starting to see all these looping problems in front of you every day, over and over and over. Welcome to programming, right? So what I want to talk about is how to break these kinds of problems down. And to do that, I'm pulling that data set, the list of student dictionaries. This is a great example of some nested data. Each dictionary in here represents a given specific student, and we have other collections. Each student has a list of grades. Each student also has a list of pets, and each pet is another dictionary. And some people have one pet, some people have 0 pets, some people have multiple pets. So this is kind of a challenging problem if we wanted to say, get the average age of everyone's pet, or get the most popular pet, or see if data science students have any horses as pets, or if those are all web dev students. So I'm going to share with y'all my one weird trick to solving looping problems. That's my clickbait title, but this will help you. This will help you tremendously in thinking about these things. So let's do that. One weird trick to solving looping problems. Here's your answer. Blow off the loop. I see a lot of learners learn the syntax for loops, and then as soon as we get into writing code that solves things with a loop, folks try to do too much at one time. This has been my experience. I've been teaching this stuff for a while. And so I want to share those nuggets of wisdom with y'all. So one weird trick to solving looping problems, blow off the loop. Why? Why would we blow off the loop? Well, what we're going to do is we're going to simplify the problem. Another way of saying that is reducing cognitive overhead. And we're solving a simpler problem. And I'll say on an emotional level, emotionally, solving a simpler problem is good for your morale. Right? If you can solve a simple version of a problem, that is more emotionally satisfying than swinging and missing at a perfect solution the first step. So there are, with the tools and software that we have as human beings, there's only so much we can keep in our heads. That's why I want to simplify things. The more we can reduce the cognitive overhead, the more we can solve one particular problem at a time. And also, we're human beings, so emotions matter. And if you try to go for a perfect solution the first time and you miss it, that's a good way to feel defeated, right? So by simplifying the problem, you can start to create emotional momentum. So create emotional momentum by solving simpler problems together or sequentially versus one big perfect solution the first time. So blowing off the loop. So that's all fine and good, Ryan, but show me the code. How do I actually do this? Let's break this down. I'm going to make an exercise here about this data set. This data set, we linked to this in the 20 data manipulation exercises. In case you hadn't seen it, it's linked to the curriculum. But let's say for our exercise, we want to answer the question. Let's start kind of simply. How many? Let's do grades. What's the average of all student grades? So this is, when we look at it initially, we see a list of dictionaries where one key is another list of numbers. So we kind of have a gnarly problem already. And I want the average of just everybody together, regardless of web dev, regardless of data science, whatever. And we see we have different students, their coffee preference, the course that they're enrolled in, and then the grades. So step one is to blow off the loop. And what that looks like, what that actually looks like in the code is mentally, we blow off the code, the loop, right? Both mentally and in our code. Then step two is we make a singular variable that holds the first element, the first item on that list. We're going to iterate. So let's do this. Student equals students bracket 0. Are y'all with me so far? I'm blowing off the fact that I have a list of all these listed dictionaries, and I'm just going to work on one specific student here. Now, step 3 is we've got to figure out, okay, what is the question asking about if we only had one thing from that list? In this example, our problem is average the grades. That's not too crazy, right? So step 4 here is we have to think about and plan out what we need to do to solve the problem in a singular case for one item from the list. And as I'm looking at this, I'm thinking, okay, grades, overall grades I'm going to make an empty list here. So I know I need a list to hold all of the grades we'll end up seeing. And what I want to do here is, if there's another list, like on this dictionary, right, on the student dictionary, we see that student bracket grades gives us the grades. And I realize I just told you to blow off a loop. We're still stuck with another loop, but we have to figure this inner loop out first, right? So let's iterate through the list of student grades, add them to the overall list of grades, and calculate sum of grades over the length of grades to get the average. So what that looks like is we will say for grade in student grades, I'm going to take this grades holder. I might even make this a little more explicit. And before I get too carried away, all I want to do is print the grade. Just double check it. 70, 91, 82, 71. So I've sanity checked myself. Now I can say all grades dot append that specific grade. And when I look at all grades, I can do a sum of all grades over the length of all grades. Strangely, there's not an average function built right into base Python, but we'll be using imports pretty soon. Nothing too crazy at this point. Unless it is. Anybody see anything crazy at this point? All I'm doing is adding grades from one list to another list. Now here's something that is kind of neat. If we were to, instead of assigning the student to be this first student, if I manually change this up here to be the second student on the list, instead of Ada, it's Thomas Bayes. Thomas Bayes has different grades. And if we run this, I'm going to comment out the all grades again. If we run this a second time, we get the first student's 4 grades and the second student's 4 grades. So we have this line of code that works pretty well for a single student at a time, where I'm manually changing the index of which student we're looking at here. Are y'all tracking that this solution is working, but right now it's only working for one student at a time? It's a yes, no question, folks. Okay, cool. Thank you. I thrive on feedback. So we have this wonderful scenario where we have the right answer, but now we need the right answer for everybody, right? So check this out. Instead of manually going in and reassigning the index here, what we can do, this is going to be wonderful. So now that you have a solution that works for one thing on that list, we can bring the loop back. So I'm going to copy and I'm going to paste this code down here as a proof of concept. And instead of student being one student at a time, I can now bring the loop back and say for student in students. And then indent that. If you've got code that solves the problem for one item on a list and you need it to run on the entire list, take that code, put it in a for loop. And then we have all of the grades everywhere for everybody. That may have happened a little fast. So step 1, blow off the loop. Step 2, ask yourself what you need to do to one specific item on that list. Step 3, you figure out whatever the algorithm is, the sequence, the selection, the iteration, whatever the algorithm is to solve that problem for one thing on that list, one student, get one student's grades. And then once we have that solution that works in one case, because we had this little pattern of just focusing on one, now the variable that holds one single student, instead of manually setting that, we can have the for loop declare and assign that variable called student, so that the first time through the loop, it holds the first student. Second time through the outer for loop, holds the second student. Third time through the loop, yada, yada. And if we have all the grades, then we can take the sum and then divide by the length. Please. Dent? I don't understand. Like this?
Yeah, just anything else. Still get the same result.
Well, this is going to give us a variable name error when we see student down here. These two things are different. These two things need to be the same. See how I replace student with X? Well, we don't think in terms of X's and Y's because we're human beings. We think in terms of nouns, don't we? So I want you to name your variables exactly what they are. If you have a list of things called students, then the variable that represents each and every single one of them should be a singular student. Just like if you had a variable for seeds, you would say for seed in seeds, for car in cars, for people in person. There's a lot of like little language tricks underneath this that help us think more clearly about the problem. But yeah, the variable that you define in your for loop here needs to match whatever you're expecting it to be inside. But again, X doesn't make sense. A specific student reads more like English. And once I have all the grades, I can sum them and divide by the length of all the grades. And now we have the average grade of all of the specific individuals here. Yeah.
substantiate the variable. I was wondering when you cultivate your for loop, the variable is still.
Oh yeah. What is this going to print? You want to bet?
I got a nickel.
A nickel? Yeah, you're redefining a variable with a for loop. Yeah, if you've already used it, it's gonna redefine it. Yeah, it's an important sequence thing to wrap your head around. Yeah. Awesome, cool. Yeah, I see your hand, Arsene. Go ahead.
I had the same problem. I mean, not exactly the same, but I didn't understand how you could come up with just student and it would just, I would say, understand that you're talking about student in students, but it's a little later that I realized it's just when you name for students in students, it understands that the variable that you're creating students is a member of the entity that you're talking about students. Yeah. And it's a renaming process that you're doing. But like I had a hard time wrapping my head around that because I was thinking that I needed to find a name that exists in the dictionary, or you know what I mean? Yeah.
See what I changed on the screen here? I said for your new variable in the list 456, you're in control of your variable names. This gives you the power of naming things, also the responsibility of naming things. This could be your new variable. It could be Y. It could be UI. Doesn't matter. X. But these don't give us much information. There's no semantics behind X or your new variable. There is semantics behind naming a variable student. Then I know, oh, that's going to represent each and every specific individual student, not every student, but one specific student as I go through there. Yeah. Would y'all like to work through another one of these challenges together? Okay, let's look at the challenge. And I got some questions about these earlier today, and I think these were really great questions. So some students have pets. Some students have no pets. Some students have multiple pets. So how could we count the total number of pets? So let's say that that's our problem. So our exercise here, count the number of, let's build another layer here. Count the number of pets from data science students in the above data. Perfect. Are we pretty clear on what we're doing? The total number of pets by program. And this begs the question, what is step one? Blow off the loop. You got it. Blow off the loop. Okay, so we do this mentally, and we literally don't write a loop yet. Just don't write it. Step two, what's step two? Y'all recall that? Set a singular variable for the first thing off that list, off that collection. So student equals students, plural, bracket 0. And we have something. So step 3 is determine the algorithm or the sequence, selection, and any other iteration to solve the problem, the original problem, for one single item. Your one single item might be books, it might be trucks, it might be cars, it might be medical patients, it might be students, whatever. And in this space, I'm thinking, okay, number of pets is 0. Like a good plan with counting algorithms is to start with a counter of 0, right? We don't have to make it terribly challenging. We started off at 0. And I might revisit this problem and share a couple of approaches. We'll set number of pets as 0, right? Okay, that's good. Well, now we have to ask a question about our single student. Is this a data science student? So how do we ask if this student is data science programmatically?
Course.
Student bracket course. And I think the data science is just data space science. Yeah, perfect. So we can access the course for that student with the dictionary access syntax. All dictionaries are labeled lists. And we can compare this to data science, right? That gives us a true or a false. And if you have a true or a false, you can then do selection. If student is data science, then we're going to do something else. If the student is not data science, we just ignore them. In this case, I don't have an else, right? But if they are data science, what I want to do here is say number of pets is, we're going to increase. We're going to do one of those little plus equals. I'll show you what I mean. So students at the course, or not course, but student pets is itself a list, even if it's a list of dictionaries. So we can ask how many students does a pet have? How many pets does this one specific student have? Programmatically, the length of the pets array or the length of the pets list that they're sitting on. Let me break this down a little bit. I'm going to remove the list length. Yes, there is a compound data structure in here. There is a dictionary, but it's a dictionary of one thing. So what I can do here is I say, if we have a data science student, then increment the number of pets by the length of that student's pets array. And then we can print out at the bottom number of pets. And since this first student is not data science, I'm expecting a 0 there. And that should track. And I'm here to tell you, if you've made it this far, you're already done with the problem, almost. You're like 99% of the way there. So what do we do now? If I want to double check my work, just to make sure that this works for not a web dev student, but a data science student, let's change the index. Okay, well, Thomas Bayes has no pets, so this should still be 0. Okay. What about if we change the index to, here we go. Grace Hopper has a dog and a cat, right? So when we define that, this should be 2. And we're tracking. The length of the pets array or the pets list is 2. Number of dictionaries on that list is 2. And so this little chunk of code right here, along with that accumulator of 0, that counter of 0, I can use all of these things. Step 4, bring back the loop. Bring back the loop. Are y'all ready to bring back the loop? All right, let's do it. So now we're going to start with our accumulator at the top. Number of pets is 0. And then instead of manually selecting one student, I do, you guessed it, for student in students. And then I paste my work, fix the indentation, and I'm done. one of the reasons I try to put the code I try to blow off as much code as I can is like we talked about, solve a simpler problem, get some emotional momentum. And I realized this might not be the most challenging thing y'all have worked with in the course yet, but we were still able to break this down and arrive at a programmatic solution that worked for a list of 10 students, a list of 1 billion students. This is just going to chew it up. I realized I made a couple of extra little cells of code here. This is part of my step 3, determining what the algorithm was to solve the problem for just one case. This may get more complicated if you have nested data, right? So if you encounter too much complexity, see what complexity you can blow off and bring back later. And usually it's a loop, usually. And when I look at loops and think about looping problems, if I see one list, I think one loop. If I see a list of lists, I think 2 loops, ultimately. Cool. Floor is open for y'all's questions right now. Yeah, Arsene.
So for me, it's rather a suggestion. I found that it's useful for me when we do something like this, like to take, I don't know, maybe like 10 minutes, and then I personally go through it myself.
Yeah.
And then like while I'm doing it, it can raise questions.
Okay.
But like if we take too long, then I get stuck and then like I'm in a loop myself. But if it's like 5-10 minutes,
yeah.
Yeah. So I'm wondering how that would be, how it would be possible to include that in the process of the class daily. But I mean, you don't have to answer it right now, but it's
yeah. When you start working on an exercise, give it a chunk of time. And if you're stuck for too long, 15 minutes, 20 minutes, you do some Google searches, no benefit from those, or if you don't know what those mean, let us know how we can help. There's the algorithm.
All I mean is like this when we're doing this right now.
Oh.
Not just the exercises that we do daily, but those explanations that you give. Like when you do that, a lot of it hits me, right? Like I can see how the progress goes. But then if I have like 5 or 10 minutes to go through it and then come back into the session immediately, then it's even more helpful. Yeah.
Okay. Let's see.
But as I said, like it's not something that I want an answer just right now, but.
Got it. Cool. We got like 90 minutes till the end of class. I think we might be able to do something with that. If everybody's on board with that, that means we're going to push imports to tomorrow. Maybe. Let me think about that and take a look at our timing, Arsene. I think everybody might benefit from that potentially. Yeah. Question from Mindy?
If we go to, the only thing I'm confused about is why we need the plus equals, since the number of pets is 0 right then.
Mm-hmm. If I only had assignment here, I would only... So the plus equals is an appending operation. Mm-hmm. So think of when you walk in the door at a restaurant, your bill is 0, right? And then when you order tea for $1.99, our total is now the original total plus 199. And then when we order this, the order of spring rolls, our total appends up by $6.99. And then when we get the curry, we append up. See how I'm keeping a rolling total with the plus equals?
Yes. So, because it's a loop, so it's going to, like, for every student, go back.
Correct.
Right?
It's gonna increment the number of pets by each data, by the length of the number of pets of each data science.
Okay, that makes sense. Thank you.
And if we didn't have a plus equals, if we just had like a reassignment, then the first time through the loop, we'd get the number of pets for the first student. And then the second time through the loop, we would overwrite that information. We would lose that data. Yeah, that's why the plus equals is there.
Oh, that makes sense. Thank you.
Yeah. Yeah, cool. This is pretty important stuff. So I'm going to let y'all in on a little bit of a secret. It's not a total secret. It's an open secret. Pretty soon, we're going to introduce some tools that make loops and conditionals a lot easier, like this much easier. This much easier. That's a lot. That's like this much, like a little kid, like this much, right? But being able to work with raw Python data structures without fancy libraries is critical, right? If you put it on your resume, right? I know some of y'all worked on this, on these bonuses, or not, yeah, some of these bonuses with the extra students here. Would y'all like to, let's see, has anybody completed these, all of these students? 1, 2, just a couple, 3, okay. Most of them, okay. All right, cool. Kudos if you've already done these. What I'm gonna do as part of Arsene's request, and if it's okay with y'all, I'd like to assign y'all some of these bonuses. Not as bonuses, but as like what we're gonna work on right now. And what's that? Cool. And let's break this into a couple of chunks. We've got about 90 minutes left in the day. So I don't just want to give you exercises and then check in at the end of the day. I want to break it up a little bit. So let's find those exercises. We'll do a review of some of them, maybe about halfway through, like a little bit after 4. Let me find those exercises for us here. And if you have already done these bonuses, good on you. Let me know if you need something to work on. Because I assure you, we have plenty. Because there's no end to the learning in this space. So what I'm going to do is stop my recording.